Hi, a partial differential equation is given by this expression y prime plus px y equals to qx. Now, as you can see, for a partial differential equation, the highest order of derivative for the variable y is 1. Alright, so this is equivalent to writing dy dx, okay? And then there is a y term over here, okay? And the p and q are both functions of x. Okay, so this is the way in which you first represent the first order differential equation. And once you have it in this form, okay, then what we do next is to define, okay, e to the integral of p dx as equals to mu of x. Okay, now once you can solve for mu of x, you can write the final expression as y, okay, mu of x equals to integral of q mu of x dx plus c. Okay, so these are the three steps that you need to follow in order to solve a differential equation. Okay, so the first step is you make sure that the equation is written in this form. Okay, next is to solve for mu of x, and the third step is to write the expression for y in this form. Okay, of course the best way to really learn how to do it is to work on a actual sum. So let's go ahead and do that first. Okay, so the sum we're going to work on is given as this: y prime plus 2 over x of y equals to 4x. Okay, now the first step is to equate this expression with the standard expression which we just saw, y prime plus p of x y equals to q of x. Now you can see that y prime and y prime is defined to be in the same position, and we have a y and y over here, so that means px is 2 over x, and finally qx is 4x. Okay, so once we are able to represent the given question in the standard expression, we know what is px and qx. Once we know that, we can go ahead to solve for mu x, which is given as e to the integral of p dx. So that will be e to the integral of p is 2 over x dx. Okay, so for this you need to remember your integration rules. Okay, so 2 is a constant, so I can write it as 2 integral dx over x, and the integral of dx over x is ln of x. Okay, if you remember your logarithmic rules, you will know that the constant in front of the logarithm can actually be brought as the power. So this is equivalent to writing as e to the ln x square, and e, which is the exponential function, and the natural log are complementary, which means that the final answer for this is given as x square. Okay, so that is your mu x, your x squared. So once you have the answer for mu x, you can write the final expression, which is y mu x equals to integral of q x mu x dx plus c. Okay, so what you have is y x squared plus, here is equals to the integral of 4x squared. Qx, as we just saw, is 4x. So this is 4x over here. and mu x is x squared dx plus c. So here you have 4x cubed dx plus c. Okay, so 4 is just a constant, so you can bring it out. Integral of x cubed is x to the 4 over 4 plus c. Okay, so this 4 and 4 can cancel off. So what you have is y x squared equals to x4 plus c. Divide everything by x squared, I'll get y equals to x squared plus x to the power minus 2 c here. Alright, so that is basically your final answer for this question. Okay, as you can see, we have solved this question following the exact same steps as what I described earlier. The first step would be to make sure that you have it in the standard form, and from there you know what is P and Q. The next step would be to solve for mu, and the final step would be putting it all together, okay, in the final expression, and then performing the integration and solving for y. Okay, so I hope that this video has given you a good idea on how to solve for first order differential equations. Look out for more such videos so you can get more practice and become better at it. Alright, thank you for watching. I'll see you soon. Bye.